this is area between curves. Area between curves. All right. So I'll start with this. There's a formula for this, and you all are going to develop the formula for us. So I'm going to do, hey, I don't know, y equals x. I'll just plot the 1 on the x-axis. Y equals x is a straight line, right? Cool. What I want you to do is go back to Calc 1. Think about Calc 1. I was wondering if you could give me the area underneath y equals x and think of some mathematical way to do that. And I'm going to give you another problem to work. We're going to find the area under, and I think I'll just go up to 1 again to keep this simple, our first example. Let's get the area under y equals x squared. Y equals x squared is a parabola, right? And I just want the area underneath the curve from 0 to 1. So I'll make another wall. So the area underneath y equals x from 0 to 1, the area underneath the 0 to 1 from y equals x squared. And you don't have to tell me the answers to these, but I was wondering if you could tell me the method. Going back from Calc 1, it was something you learned in Calculus 1, the method to find the area between that function and the x-axis. What do you do? I heard it. Take the integral. She goes, take the integral. So I'm going to take an integral of this. I'll go from, what's the x values? 0 to 1. I'll put the function x, and then we'll just write dx, right? So do you agree that would find the area under here? All right, you get the area. That gives this area. Well, what about this one? Very similar. Let me shade it in. What would be the area under this? Well, that'd be the integral from 0 to 1 dx, right? Well, what goes here? X squared. Two separate problems, but you know what to do, right? And I mean, of course, we can evaluate this. But you and I are now like, well, we're in Calc 2 now, we're going to get the area between curves. So the problem at hand for us, everyone, in section 6.1 is this. Can you find the area between here, y equals x, and here, y equals x squared? Hey, they do meet at x equals 1, don't they? So I'm going to shade this. And you're going to create a formula for the class. Watch how the students in this class will develop the formula for this. How do we find the area between two curves, or two functions? You know?
The top minus the bottom.
He goes the top minus the bottom.
For the integral.
He's looking at this and saying, if you put this inside of here, you had to get the difference. He's saying, just take the difference of these two, right? So we'll just subtract. It's like, I can get these two answers and subtract them. That's the math formula. So he said, the math one for us, I'll put it right here, is we'll just go the integral, some function f of x minus some other function g of x, if I'm getting the area between the curves. Here, I'll put dx. I like how you said top and the word bottom. He said top, but you didn't think that way. Because which one, everyone, if you look at this picture, which one's really on top? And you look at it this way, the y equals x. And which one's on the bottom? Y equals x squared. He's saying if you just subtract these, you'll get the difference between them, and you'll get the area in those squares. So that's what I'd like us to do. Can we just do this math right here? I'll raise these two, and we'll set up our problem like this. We got it. Take the difference of these two. Get all this out of the way. We can do this in one integral, right? Sure, I could have taken that answer and subtracted, but we're saying go from 0 to 1. Who's the top, though? X or x squared? Good. Good. You can put a parentheses around this. And just, let's see what we get. What's the antiderivative of x? X squared over 2. What's the antiderivative of x cubed? I mean x squared.
X cubed over 3.
X cubed over 3. We'll go from 0 to 1, plug 1 in these two values. Then we'll plug 0 in the two values, we'll subtract them. Now let's see what we get. Okay, I get a half minus a third. 0 minus 0, I like zeros. The only thing is I need a common denominator, huh? Well, if this annoys you, pull out the calculator and calculate that. But I know that's what, 3/6 minus 2/6? What's 3, 6 minus 2, 6? What's the area? 1, 6. It's the exact area in that curve. Thank you for developing the math formula for the course, right? There's our first formula for our course, area between curves, top minus bottom. F of x minus g of x, single integral. I think the only challenge will be finding these a and b values. When they get us two expressions, we got to know where they intersect, right? So we got to use those old algebra skills of how do I find where two equations meet each other, or two functions meet each other. Is that going to go there? Excellent. All right. So let's try one. We're like, hey, can we go a little bit harder than this? So this is, I'm picking a problem. It's like one of the practice problems I was mentioning. And I made this one up. How about this? Here's one of the functions. F of x equals 4x minus x squared. My other function is function f of x equals x squared minus 8x. If you're curious, if you want to know which problem this is like from the textbook, it's like number 13 from section 6.1 if you're curious. It's like number 13. All right. The question. Find the area between these two curves. Find the area between the curves. Now, right now, everyone, unless we make a picture, I don't know who's the top and who's the bottom, right? And we don't want to be guessing. So we'll make a, not be a perfect picture, but a decent picture. Isn't that looking up you? Good. Negative x squared. Wouldn't that be like this? So I'm going to make a picture in a sentence, but it looks like we've got like a what? Something like this, and it looks like you got something like this. Who do you think's the top? Just your guess by just knowing so far.
X squared minus x.
This one. Now, negative in front of an x squared makes the graph's going to look like this. That looks like that's going to be the top one, right? It appears you're going to be the top, you're going to be the bottom. Now I just did a what? A freehand drawing right here, but that looks like what's going on. The problem is when we set up that integral, we got to find these important limits of integration. Where do these two things meet? True? Now that was a sloppy picture. If you wanted a better picture, it's like, let's see. If I factor that, when x intercepts, I just have to set y equal to 0, right? If you want a decent sketch, you can make it with a calculator. If I wanted to sketch that a little bit better, let's just find these x-intercepts. I backed out an x. It looks like it meets the x-axis at 0, 1, 2, 3, and then over at 4. So this graph's doing something like this. Right? How about this one? Now when you want to factor that, just to see where it meets the x-axis. X and what? 8? Okay, so I better extend this a little bit further so you can see it. I'm just making a decent picture. 5, 6, 7, 8, and in here, this thing's going to do what? Down here and then come back up like this, maybe? It's not a perfect sketch, but what area are we looking for? All that. When we're looking for this entire area, we've got a math formula for it. The only problem is, we've got to find out what they mean. So first, I'm going to set up the problem. To find the area between the curves, draw an arrow. It will be the integral of top minus bottom. Who's the top? 4x minus x squared, right? That's this one. Who's the bottom? That one. The only challenge, you all know this, daggone it, where do they meet, right? Now when I already have a typo on purpose, I have an error up on the board. I didn't want you to make this during an exam. Or in your practice. I didn't even put these down, I've already screwed it up. Anybody spot it? Oh, look, the hands are up. They're like, they know. What do I need right there? Parentheses. Where some of you distribute automatically, you got to subtract the quantity of that other expression. So very good seeing that. Now these two things, we need these numbers. I'll just put question marks for now. What are these two values? How do you in math find where two functions meet each other. What do? That's right. And we can do the substitution method, where we can take one and substitute the other, vice versa. He said set them equal to each other. So when I got 4x minus x squared, that's, and isn't f of x just a y? So if you can think of this, all right, you're like y, and this f of x is another what? Y. He's saying because they're both y's, set them equal to each other. Go off to the side of your paper, then we'll come back to this, we'll find these two numbers. So, does it show over here? Hey, all right, so I'm going to do it right here. Where does 4x minus x squared be equal to x squared minus 8x? I'm doing this to find where they meet. So I'm just going to put on top of this, meet, question mark. Where do these two things meet each other? And how do I solve something like this? When I'm going to add x squared on both sides. I'll subtract 4x on both sides. 0 equals 2x squared minus 12x. Can you help me solve that? We don't need the quadratic formula. Can we factor that? What can I factor out of that? X, factor out an x. And anything else? A 2. And when I factored out 2x, I'm left with x minus, so what are the 2x values where they meet? X equals 0, and x equals 6. Some of you might have guessed it from the picture though, huh? Right? But I didn't do the best picture. And look, this was not drawn to scale, because this would have been right at what? Right around the 6 mark. Right at x equals 6. Let me get this out of the way. Right there, the meeting. Hey, that's something you can also explore with your calculators, true? But you'll always be able to find algebraically where these two functions meet each other. Great job. So let's go ahead and solve this. Should I start doing antiderivatives or should I collect like terms? That's up to you. I'm going to collect like terms first, inside here. So let's see, what's 4x minus x squared plus 8x. What do you get? I just thought I'd collect the like terms first. You get 12x minus what?
2x squared.
2x squared, all right, 12x minus 2x squared. So far so good? What's that antiderivative? 12x squared over 2 is 6x squared? Antiderivative this. Minus 2x cubed over 3. Oh, I love zeros. All I got to do is plug that 6 in there and subtract them, right? And you know this. Doesn't the answer have to be positive? All right, what's 6 times 6 squared? That's 6 times a 6 times another 6.
216.
216. Thank you. What's 2 times 6 cubed over 3? So that would be 2 times 216 over 3. I think 3 goes into 216, doesn't it? 72 times? All right. Oh, by the way, I can do it, but when I plug zeros in there, what do you get? 0 minus 0, good. What's 216 subtract? That's 72 times 2. What's that, 144? You can use your calculator too to see that. All right, what's 216 minus 144?
72.
There's your area. We got it. There's our area. It is positive. We knew it had to be positive. Let's see if you have any questions on that problem. Yes?
Why do you want us to positive?
Why is it always positive?
Yeah.
Super question. As long as we set it up properly, as the top minus the bottom, it will always do that difference and give you a positive answer. So isn't that cool? Now, this has happened before. What if a student did all this work properly, found these numbers, but accidentally did the bottom minus the top? What do you think would come out as their answer? Negative 72. So if that happened during a test, what do I recommend? You're like, okay, you can just recognize, you go, whoops, I did this, I'm seeing it now, and draw a picture, maybe say, here, I should have had this on top and bottom. You don't have to erase it.
Formula can be like 1 minus the other, I think the absolute value.
It's brilliant, everyone. Hear what you just said? she's creating a side formula. She goes, you know what, here's another formula. I'll put it here, but this is Sean, right? Sean's formula says, you can think of it like this. If you mess it up, now look where I'm putting the bars now. If you accidentally mess up the top and the bottom, right? She's saying just as long as you do that, you're still going to get the mathematically correct answer. You see that? That's called Sean's theorem.
But that's not like logically correct? Like,
It's true.
Oh, okay.
Isn't that cool? Because it will happen where I'll go, oh man, I had these switched.
Yeah.
I meant to do it and I still wrote it wrong. And you're like, well, by Sean's theorem, I'm just going to take the S right there. Just make sure, hey, be careful. Don't put the bars here. That's something totally different. Right? If you put the bars inside here, that'd be different. She's saying like the absolute value of the final answer. Hey, Sean's theorem. That was good. I like that. Hey, you can think that same way, everyone, when we get to 6.2. What she was just talking about. I want you to think that way. If you accidentally make an error and go, wait a minute, can I still do something like that? What you're just doing. That would be in case I messed up the top minus the bottom. Okay, great. So we're like, man, I think we've got this section conquered. Well, there's a couple more scenarios. I mean, what are we going to do in this scenario? This happens a lot. Not everything's a function. Not everything's a function. And so, y is a function of x. Passes the vertical line test, right? So you might get something like, oh, I don't know, a graph like this, right? You might get some graph that looks just like this. And, X and the Y axis.
You might want to grab a seat or something.
So in this case, is this a function?
I'll turn the camera off for a second, okay?